Yay! Little by little. Problem 22. So problem 22, we're looking at the angle of interest is 38 degrees and x is the adjacent, 10 is the opposite. And so we're looking at another tangent ratio for 22, but in this case, my tangent of 38 is equal to 10 over x. So with the variable in the denominator, I'm going to pull a switcheroo on this one. X is going to be equal to 10 divided by tan 38. 12.8 would be my missing length there. X is approximately 12.8. And then next, 23, the angle between the bottom of a fence and the top of a tree is 75 degrees. They've got it marked here for us. Let me just actually pull this drawing off so it's not messed up with the tree there. There's my 90 degrees, 75 is here. They say the tree's 4 foot from the fence. They want to know how tall it is, so the X is over here. So from that 75 degree angle, X is sitting on the opposite side, 4 is sitting on the adjacent side. And then for my problem then, 23 is going to be set up as the tangent of 75 is equal to x over 4. When I multiply both sides by 4, the height of the tree is 14.9 feet. Oh, they said to the nearest foot, 15 feet. It said round to the nearest foot, so I'm going to go to 15 feet for that. Now when we move from section 9.4 to 9.5, we're looking at sine and cosine. Remember, this was building up to us solving, so reviewing all the basics of the things we needed as we moved up to solving triangles. Our sine and cosine ratios, there's some examples here. We move over to problem 24. In this case, with 24, 25, 26, they're just asking us to go and write what the sine and cosine ratios would be at, write it as a decimal, rounded to 4 decimal places. If I go in at angle X, so for X, I'm going to have that highlighted in yellow here. Sine of X, when I come in from angle X, opposite is 3, hypotenuse is 5. Sine of X equals 3/5. I know for a fact that that actually is the terminating decimal, 0.6. Cosine of X is going to be the adjacent, which is 4 over the hypotenuse, and that actually is 0.8. Those are terminating decimals. Then, if you remember correctly, when we go to another angle, the sine and cosine of sine of Z is going to be 4 over 5. It's the same as the cosine of X, and the cosine of Z would be the same as the sine of X, 3 over 5. So for 24, we got sine and cosines of both angles, and then reduced fractions down to, again, those are all terminating decimals. Let me go in at Z over here first. When I go in at Z for number 25, the sine of Z, that's the 7. The sine of Z equals opposite 10 over square root of 149. Cosine of Z equals adjacent, which is 7 over hypotenuse square root of 149. Let me go into my calculator on these now. 10 divided by square root 149. I got 0.82. And I also have, that's weird. Oh, not really. 7 divided by 149. Oh, wait, we had to round further. Sorry, I said 4 places. I just chopped that one off. This would be 8192. And 7 divided by 149 would be 0.5735. That last digit would round up. When I go into my other angle, when I go in at X, sine of X is going to be the same as the cosine of Z, 7 over root 149. Cosine of X is going to be the same as the sine of z, 10 over root 149.8192 there. So once we find one pair, the other angle has sine is cosine of the other angle, cosine is sine of the other angle. When I go on to 26, for problem 26, let me start by going in at angle Z over here. Sine of angle Z opposite is 48, hypotenuse is 73. I got approximately 0.6575. Cosine of Z is adjacent over hypotenuse, 55 over 73. That's going to be equal to approximately 0.7534. When I go at sine cosine for angle X, sine of X is going to be the same as cosine of Z, 55 over 73. X and Z angles are complements from each other, and the sine cosine relationship will always hold true. That's going to be 48 over 73.6575. Now this was just testing whether or not you could identify the opposites and adjacents and whatnot. And now we're going to actually use these functions to do some solving. So in problem 27, we're going to label up what we have related to the angle that we had. Number 27. They want us to find both parts here on 27, and we have one angle of interest. So when we have one angle of interest, the nice thing about that is I could find out what the other angle is, but I don't need to. When I have the single angle that's given, that allows me to go through and label opposite, adjacent, and hypotenuse, because I'm not moving away from looking in at that angle. Hypotenuse would be the 34, opposite 23 would be the T, and adjacent to the 23 would be the S. So if I'm going to find T, I've got to relate T to the 34. That's opposite and hypotenuse, so ka-toa. So sine of 23 degrees equals T over 34. And I undo dividing by 34 by multiplying both sides by 34. So your T, and they wanted these rounded to the nearest tenth, 34 times the sine of 23 is 13.3. 34 times the sine of 23. You should have T as this. Now cosine of 23, yep, is going to be your S over 34. Multiply both sides by 34. $31.3, yep. S is approximately 31.3. So moving to 28, 5 is the hypotenuse, R is adjacent, S is opposite. So for problem 28, sine of 36 is going to get us to solve for S over 5, opposite over hypotenuse. And if I go do the cosine of 36, it's going to be my R over 5. In both cases, multiply by 5 to get that out of the denominator. I'm going to go to my calculator in a second here. S would be 2.9. Rounded, it'd be 2.9. It was 2.93. And R would be 4.0. It was 4.04, so I just round it to 4.0. 29, same idea. Opposite is V, hypotenuse is 10, adjacent is W. So for problem 29, sine of 70 is going to be V over 10. Sine of 70 is going to help me solve for V. That's V over 10. Cosine of 70 is going to give me W over 10. And in both cases, multiply both sides by 10 to undo the divide by 10. Ten times the sine of 70 is 9.4. That's my value for V. 10 times the cosine of 70 is going to give me 3.4. That's my value for W. Now, probably one of the easiest things that we did in all this section was what's going on in 30 and 31. Right, sine 72 in terms of cosine. That means then that I have to take the cosine of the complement of 72. Complements add to 90. Sine of 72 would be equivalent to the cosine of 18 degrees. In problem 31, the cosine of 29 would be equivalent to the sine of 90 minus 29. And that would be sine of 61. So it's that complement relationship for those. Problem 32, now we're knee-deep in, we've got to solve. Solving right triangles. What are we given? What do we have? How do we proceed? I'm going to get some new paper to do that. Oh, 32, 33, 34, good. We've got just a couple solving. 32, I got to go pull cosine inverse of 0.32 and find angle Q. In problem 32, 33, 34, just using our inverses. Inverse cosine on 0.32 is putting this at approximate to the nearest tenth. Fantastic. Angle Q is approximately 71.3 degrees. In problem 33, sine inverse on the 0.91 is going to give me my angle Q. Sine inverse on 0.91 is going to give me 65.5 as the approximation for angle Q. Bless you. In problem 34, tan inverse on 0.04 is going to give me angle Q. And that's going to be approximately 2.3 for the measure of angle Q. Tan inverse of 0.04. Yeah, that's a really dinky angle, but it is what it is.